Okay, so measuring segments and angles. So this is our I can statement. That I can statement is basically saying this is what you're supposed to be able to do after the lesson, like is complete. We broke this up into 2 days, so it won't be complete until tomorrow. Right? So it says I can use properties of segments and angles to find their measures. So vocabulary, collinear points, line, plane, point, and postulate. Someone tell me, what is a collinear point? Now would be a really good time to take out those vocabulary sheets. Yes. All right, so points that lie on the same line. Perfect. What's a line, though? Who can tell me that one? Go ahead. Yep. Perfect. So a line just keeps going and going and going and going and going. It doesn't stop. Why did that pop up? Okay. What is a plane? You can tell me what a plane is. I'm not talking about that thing that brings you to exotic destinations. Yes. Very good. So we're talking about a plane of space. If we look here, like right at this floor, this would be considered a plane of space. Each of you could be considered a point on that plane of space. Okay. Now let's get to a point. Who can tell me what is the point of a point? Yes.
It's a location that has no size.
Yeah, it's a location that has no size. Okay. Now you guys clearly have a size, even though you're like right now points on a plane of space. But is that point in space always determined? No, right? My fingertip is considered a point in space. Like over here, right? Right? Technically, if my fingertip kept getting smaller and smaller and smaller, I'd still be a point in space. But I'm not a defined point in space. It could change. It has, what do we call this? It exists because it has to exist to get the whole geometric system that we have, that we're going to learn about this year. Okay. What's a postulate? Good.
A postulate is a statement that is assumed to be true.
Yes, it's a statement that's assumed to be true. It does not require proof to be true. Usually what happens is theorems require proof to be true. Postulates are formed from true theorems. They exist because of those theorems. Okay? We'll get a little bit more into that a little later. All right, but I promise you, that's why. All right, any questions on the vocab? All right, so here's a good check for you guys. Just check to make sure you have the right definition with the description, okay? The notation that we need to use, and the notation is very important in geometry, is anytime you're dealing with a point, you use it as you use a capital letter. In this case, this is point P. For a line, you use 2 points in space. Do not use 3, do not use 4. I don't care how many points they give you, you only use 2 because it helps determine direction. In this case, we have line AB. We could also call this line BA. It can go either way for lines. Okay? This is a plane. We can name this one of 2 ways. We can name it plane M. Usually there's an italicized letter kind of up in the corner to define the whole plane. Or if you have 3 points, pick 3 points. If they give you 10 points, only pick 3. Okay? Don't add them all. That's not the point. No? Moving on. I'm here all week, guys. Don't worry. There's going to be more bad jokes coming. If you think your dad tells bad jokes, just wait. Anyway, here's the next round. We have a segment, AB. You could also call it segment BA. Again, can go either direction. Rays are a little bit more precise. Okay? Anybody ever used a laser pointer before? I know I have. It's okay. Hopefully use it for good, not evil, right? Or maybe we'll use it to give a cat some entertainment, right? Yeah. If you click that laser pointer, it has a start point, and that's at the laser pointer itself, right? And then it continues on and on and on and on until in space. That's right. That's a ray. It technically never stops until you remove the button. Okay? So in this case, because of that, we can only name rays based off of that start point and then the point it is going through. You cannot flip-flop these. So that's why if you look right here, we have point M going through point N, and they label it with M as a start point and then going through point N. Okay? Do not flip-flop rays. Please don't. Okay? Opposite rays. In this case, you have T going through U and T going through S. If you wanted to name another ray here, you could also call this ST. But that determines direction. Okay? You can call it U going through S, and that would be another ray. You have multiple rays on a line. It all depends on the start point you choose. Okay? So if I wanted to say, if I'm talking about going from here through to here, I can call this ray SU. And that's legal. Okay? I cannot do that NM here because this is just one ray. That is it. Now, one thing that is important about two rays at a common endpoint is that it forms a line. Okay? Angles? You can name those three different ways. If you have a single angle, you can name it based off the vertex. This is the vertex of the angle where those rays kind of change direction. Okay? We call it angle Q. You can name it using three letters. In this case, they use PQR, but RQP also works. You could also call it angle 2 because it has a number. I'm going to give you a tip. Numbers are always good because it defines the angle and the direction. However, if we had something like this, where we have two angles coming off a line, okay? RQP is one way to name this angle, then RQZ is to name this other angle that was just formed. I highly, highly recommend you use three letters. You're going to use that more than just having a single angle. Okay? So getting in those good habits now is going to be a lot better because if I said, hey, name the angles here, and you said angle Q, you have technically three angles here that contain angle Q as a vertex. Okay? And that would be wrong because I'd be like, what angle are you talking about? Does that make sense? So get in good habits now. Use three letters if you can. Okay? Questions on this? Okay. Let's take a look at our first example. You're going to want to write this down in your companion. Now, here's how the companions work. There's my companion. If you take a look here, you can write the examples, like these examples, like in the, okay, right in here. Because usually they use the same information here for the triads. All right, so you're going to want to definitely draw the picture. If you don't want to write the whole thing down, that's fine, but make sure you have at least the picture. Okay. So this says, how can you find the length of CD? Now, if I want to find the length of C to D, what can I do here? You can tell me what you guys are writing that down. A little bit closer. All right, so what's the distance? It ends up being 3. How do we know? What's one method we can use in order to find that it's 3? Go ahead. Subtraction. Okay, so that's one method. So that would require me to do this. If I'm finding CD, that's equal to the absolute value of 1 minus 4, which leaves me with the absolute value of negative 3, which leaves me with 3. It will be important that you put that in absolute values, and you can go either direction, it doesn't matter. Remember, absolute values is always positive. Okay, always positive, consistent as gravity. The reason it's always positive is because we're talking about a distance from 0 in either direction. Think of it this way. How many of you want to drive someday? Oh, scary. Anyway, no, I don't recommend it. Driving's horrible. Have you met people? Ew. Anyway, the problem is, I'm joking. This is why I work with kids. Adults are just, oh, it's driving. Oh, scary stuff. Scary stuff. You don't know how people on the road got their license half the time. If your parents are driving their car and they put it in reverse, is that odometer subtracting miles? No, it's adding miles each time, right? Because distance is always positive. And it doesn't matter the direction you're going, okay? If you're going, they're saying at sea level and then you're going below sea level, they don't call it negative 20,000 feet. They call it 20,000 feet below sea level because it's a distance, okay? It's the same thing with absolute values. It's a distance from 0, so it has to be positive. It doesn't matter if you're on the negative side of the number line or the positive side of the number line, okay? Someone tell me what's another method here we could use in order to solve for this. So subtraction is 1. There's one more, pretty easy. We've done it forever. How so? What would you do? Counting, right? Who here watched Sesame Street? Right? 1 spot, 2 spots, 3 spots, right? Sesame Street, no? The count? The count that counted? No? I would say Cookie Monster, but he just kind of puts it all in. So I can't say he does much counting. He just enjoys it. He just loves those cookies. So yeah, we can just count. 1, 2, 3. That's it. As you can see, I am not opposed to making an idiot of myself sometimes, right? Even if it is a bad imitation of the count. All right. Questions on that? So now what I want you guys to do is, now that you have it written down, I want you to work on the try it. All right. So they want you to find the length of AC. You can use either method you wish. All done? Okay. Yes.
Sorry, I didn't get everything down. Why you on the other slide?
Okay. Give me 1 second. It's over there. Yeah, grab it. Mhm. There you go. Just one. Okay. So someone tell me, what was the distance for AC? What do we got? Yep. 4. Very good. Questions on that? Okay. Moving on. So now we're going to talk about the ruler postulate. So it says every point on a line can be paired with a unique real number. This number is called the coordinates of the point. So when they're talking about the ruler postulate, they're talking about a ruler acting as like a number line. Okay. But obviously it has little more intricate parts with those fractions or those decimals. Okay. So in this case, if we want to find the distance from x to y, we know the coordinate of x is 3, the coordinate of y is 7. So we would just subtract those two. And it doesn't matter which direction you go. Okay? Absolute value of 7 and 3 minus 3 is 4. Absolute value of 3 minus 7 is also 4. It doesn't matter. Okay? So that's what the ruler postulate is supposed to do, just kind of give you those positions. Okay? So now let's take a look at this. So it says find the length of a segment. What are KM, LM, and KL? And remember, we have our definition of a postulate right here. And then it says use the ruler postulate to find the coordinates of K, L, and M. Then find the distance between K and M, L and M, and K and L. That is the procedure. Okay? So in this case, if I want to find K to M, my position for K is 12. My position for M is 27. I'm going to subtract those two, and it doesn't matter which one I put first, because it doesn't matter if you get a positive or negative after, you're taking the absolute value, giving you 15. Okay? Same thing for L and M. So we see L is at 16, so we just have 27 minus 16 giving us 11, or vice versa. K and L, we have 16 minus 12, again, 4. So nothing is too weird or out of the ordinary here. Now, you're probably thinking to yourself, well, geez, I can just count this. Why the heck are we going through this whole thing with absolute values, right? I would think it too. The problem is that sometimes, again, remember, we have those tick marks, right? And they all have meaning. What happens if you get one on a tick mark? Then you're dealing with decimals and fractions, and the subtraction method might be easier than counting. Okay? So that's why we're going over it this way. Sound good? Because you will see that on your homework tonight. Yay. I like fractions, guys. I really do. Not going to lie. All right. So now that we've gone through that, you guys, it should, I think this one gives you it does not, does it give it to you? No, it doesn't, does it? Okay, so here is the picture. You're going to want to write it down as a number line. You don't have to write it down as a ruler, okay? And then I want you guys to take care of try it 2, A and B, okay? I'll give you guys a couple moments to do that. Okay. All right, someone tell me what in this case is JK. Yes. 7, very good. What about KM? Or JM, I'm sorry, JM. Anybody? Bueller? Yes.
In the book, it says KM.
It does say KM. Okay. You're right. All right, let's try KM. How many is that? 10. 15. Perfect. And yeah, just going to let that save. Thank you for bringing that to my attention. Just noticed that. Any questions on those two? Sweet. Okay. Let's move on. All right, so the segment addition postulate, again, you already have this in your vocab, but it basically is saying that if you have A, B, and C, and they are collinear points, right? If you add this small segment plus this small segment, you get the entire segment. Makes sense, right? Okay. So let's take a look at the first example. This one says points F, G, and H are collinear. If GH is 16, what is FH? All right, so what I would do is this. I like to label things a lot. All right. So they're telling me that GH, which is represented in blue, is 16. So I am going to solve for X using that. So this will be 2X plus 2 equals 16. Subtract the 2, divide. You're going to get X is equal to 7. Now, if you're adding these together, it just makes sense to find out what FG is. So this is going to be 3 times 7 minus 1, which gives us 20. And now to find FH, that's going to be FG plus GH. And that gives us 16. Oh, I should reverse that, sorry. That should be 20 plus 16, which gives us a total of 36. And actually, if you guys look right here, it says common error. This is a big error on a test, like no joke. It says be sure to answer the question that is posed. You may think the value of X is the answer, but you actually need to use X to find F of H, FH, okay? So don't stop. If they ask you what's X, then you're good. But if they're asking you what a specific segment is, you need to find that specific segment, okay? Questions on that? All right. Now, you guys, this should already be written in the book. It says points J, K, and L are collinear. If JL is 25, what is N? And then what is JK, KL? Take a moment and solve for that. So students say when working okay, so they want you to After you find it. You gotta find them first by using the second edition. Okay. So we're gonna do that this time. The two parts and the equal. Yeah, that's fine. Yeah, I don't know how to make this work. Unfortunately. I'll work on it, guys. Sorry, it's first day. I'll see what I can do to kind of, because I'm as zoomed in as I can get, and I don't want to push it anymore. So I'll figure out something. I'm just not sure what that something will be yet. Might not happen tomorrow. Give me the weekend. Need time to explore. All right, so let's talk about A. So now this is taking that segment addition postulate and kind of flipping it, okay? So this means that if they're giving us JL, they're giving us this entire segment from here to here, okay? So that's telling me that using that as segment addition postulate, I'm going to have JL is equal to JK plus KL. And therefore, I'm going to have 25 equals 3n plus 5n minus 7. And I solve for n from here. So I'm going to have 25 equals 8n minus 7. So I'm combining my like terms. I'm going to add the 7 to each side. This leaves me with, was that 32? 32 equals 8n, and then divide by 8. What do we get for n? Go ahead. 4. So now that's for part A. Now for part B, I'm taking that 4 and I'm substituting in. This will be 3 times 4, which equals 12. This will be 5 times 4 minus 7. So that's 20 minus 7, that's 13. The question here is, does 12 plus 13 equal 25? It does. So that's a way you can check. If it doesn't equal that original, something went wrong. Okay? Any questions? Okay. Before we move on, let's talk about the habits of mind that are right under there. It says, Gina says that for any segment AB on a number line, AB is equal to BA. Do you agree? Explain. So first off, she says AB and BA are the same. Is that true? What do you guys think? Yeah. Why is it true though? Go ahead.
Because the distance between them is the same.
The distance between them is the same. Perfect. Just remember, A to B is saying, hey, we're starting at A and we're moving to B. B to A is saying we're starting at B and moving to A. That distance between the two is still going to be the same. It's just the direction's a smidge different. Think of it as like the absolute value thing, right? All right. Any questions on that? Okay. Turn to page 4 in your companion. I want you guys to do 2, 3, 5, 6, and 7. I'm give you a little bit of time to do that. Okay. 2, 3, 5, 6, 7. Yeah, you're gonna skip a little bit because we didn't do angles yet, so we'll do angles tomorrow. If you guys want to do it, we can. Let's see if you're doing what you're doing. Find it. Okay. Okay, so this one was saying that she wrote this. Question was, is she correct? And if she is, just explaining that's why she's not responding. Yeah, but was the first was. Yeah, so she made an error somewhere. Yeah, 2, 3, 5, 6. Oh. Sorry, here I can't do it. It's like it's on my drawings. Just bounces right. Okay, you see if you can. If you want, so just count how much space you have. Okay, now hold on. Start again. Sorry. No, you're right. Sorry. So I had it wrong. Yeah, don't even do your this one. Oh, that's. Yeah, that's it. When I see a random puddle just having parts of teacher. I'm sorry? Yeah, sure. Well, you guys should absolutely have it. So we have -4, -2. That should be what it is. Yeah, but it's not 1. So I'm just gonna wait. It's the same, I mean, you can still count it, that's totally. We'll just. Those you should probably just count to be honest. Alright, Johannes, you still working on these? Okay. Alright, let's talk about the first one. So the first one says error analysis. Ella wrote AB is equal to absolute value of -1 plus 5 equals -4. Explain Ella's error. Go ahead.
So it really should have been -1 minus 5 equals.
Very good. So it should have been subtraction here. And if you want to, you could have counted, right? It was not going to equal 4. There's not 4 spaces there. There's a bunch of different ways we can look at this, okay? So good job. Number 3, what does it mean for points to be collinear? How many lines pass through 5 collinear points? What are we thinking there? For number 3.
That's not one of them.
Number 3 is not your book. What does it mean for segments to be congruent? New curriculum, guys. Sorry. All right. So yeah. So you guys have. What does it mean for segments to be congruent? Yes. Is that what you have?
Yeah.
Okay. What does it mean for angles to be congruent? So someone tell me what does it mean for those to be congruent, and I will fix that slide. Yes. Very good. Okay. Yes. Segments will have the same lengths. Angles will have the same measure. I'll fix that. All right. Number 5. So this says find the length of each segment. Let's talk about WX. What was the solution for WX and how did we do it? 2. And what'd you do?
I just
Counted. Pretty easy to count that one. All right. How about number 6? WY. Go ahead. You got 9. And what'd you do?
Absolute value.
You did the absolute value. So what numbers did you subtract?
-4 and +5.
-4 and 5. Very good. And you subtracted the 2, giving you a -9 maybe, or a +9, depending on which direction you went. And either way, you would get 9. Very good. Questions on that? All right, 7. Points A, B, and C are collinear, and B is between A and C. Given AB equals 12 and AC equals 19, what is BC? I'm just checking to make sure it matches. So sorry. All right. Who can tell me, what did you get for X? First and foremost, what do we get for X? In this case. Or actually, in this case, just BC. What would BC be?
7.
7. Very good. Who needs to see that one? Okay. I'll do it real quick just to be safe. But always remember, draw a picture. Pictures are great. So we're saying these are collinear. We have A, we have B, we have C, and they're telling me that B is between A and C. So it doesn't matter where we put it as long as it's there. All right. They're also telling me that AC, so this entire thing, is 19. And they want us to find BC, and they tell us AB is 12. So this is going to be 12 plus that X value equals 19. Subtract the 12. You are, in fact, left with 7. Okay. Any questions? When do you guys get out of here? 05? Okay, we got just enough time to go over the quizzes. Homework tonight is on Realize. Okay? So just remember, go to Realize. It is on Google Classroom, so you should just have to click and you're good. Okay? All right, those of you watching at home, have a great day.